as we continue into the second half of chapter 6, we're still working with radicals. Okay, the radicals aren't done. We're still working with them. Lesson 6.5 is solving equations that have radicals, square roots, cube roots, whatever it is. You've probably worked with equations with radicals in them a little bit in Algebra 1, maybe. Okay, maybe not. That look says no way, so regardless, we're going to talk about it. Now, key comment up here as we get started. An important thing to remember when solving equations where you have to power both sides, which is what we're going to do, like raise both sides to the power of 2 or raise both sides to the power of 3, is to check for extraneous solutions. We have talked about extraneous solutions this year. We've had dealings with extraneous solutions, and extraneous solutions just happen like when you take the square root of both sides, or today it's going to be more powering both sides up. It sometimes creates an extra solution that doesn't necessarily work. Sometimes it will, sometimes it won't. So what that comes down to is we're going to want to be checking our answers today. There are certain sections, I feel like there's a specific section on the back that is more prone to have extraneous solutions, but we're just going to kind of want to be aware of that. Okay, so example 1. These first square root equations we're going to solve just have one square root. And our job is to, of course, solve for x. So the main step I'm going to tell you, or the first step I'm going to tell you, isolate the radical. Do you know what I mean if I say isolate the radical? No? Okay, good answer. I mean, isolate the radical. What am I trying to ask you to do? First of all, we know what the radical is, yes? Radical being the square root symbol. If I want to isolate it, if you are isolating at home from COVID, you are by yourself, right? Okay. So we're trying to get this radical isolated. In other words, we want this radical to be by itself. So I want one side of my equation to be the radical with what's underneath it. So in this case, I want the square root of 2x minus 3 to be by itself. What do I need to move away from the square root of 2x minus 3? There's a positive 3 hanging out over here, isn't there? How would you move this positive 3 to the other side of the equation? Okay, it's a positive 3. It's being added to this radical. And so to move that term to the other side, we're going to subtract 3. If I subtract 3 on the left, I'm going to subtract 3 from the right. So on the left, 3 minus 3 cancels. I have the square root of 2x minus 3 equals, what is 8 minus 3? 5. Okay, so step 1, isolate the radical. Get that radical by itself. Now, we need the radical to, I don't know if I want to use the word disappear. We need the radical to disappear. And this is where we talked about, up here it talks about powering both sides. What power can I raise a square root to that's going to get it to disappear and be gone? Squaring, right? If it's a square root, in order to get it to disappear, we're going to raise it to the power of 2. We're going to square it. Now, what do you guys know about equations? If we square the left side, we're going to square the right side. What you do to the left, you do to the right. Now, you guys remember the square root of smiley face times the square root of smiley face is smiley face? Okay, same idea here. What happens when I square the square root of 2x minus 3? 4. So square root of 2x minus 3 times square root of 2x minus 3. Just 2x minus 3. In other words, when you square a square root, what's happening is the square and the square root kind of cancel each other out, and we're just left with 2x minus 3. Okay? So when you square square root, they cancel each other out. You have whatever's under the radical. On the right, what's 5 squared? 25. 5 times 5 is 25. Now you have a middle school level equation.
I can do this.
I would like to think that everyone sitting in this room can do this one. This one's pretty basic at this point. I'm not saying they're always this basic, but if it's 2 times x minus 3, what's the step we take to solve for x?
You subtract or add 3 to both sides.
Okay, if it's 2 times x minus 3, we're going to add 3. If I add 3 on the left, bless you, you add 3 on the right. So, on the left, minus 3 plus 3 cancels. I have 2x. 25 plus 3 is 28. If it's 2 times x, what do? Divide by 2. If I divide the left by 2, I'm dividing the right by 2. X equals 14. Okay, that's it for that one. Some of them will be easy today, I promise. Okay, the key is remembering step 1 here. One thing we always have to remember to do is we're going to isolate the radical. Okay? Just like when you get sick and you have to isolate at home with COVID or from COVID. Same thing here. Okay. So I got the radical by itself. I isolated it. Then I squared both sides to get rid of the square root. And then I solved that equation. Think you guys can do the next one? Already did? Awesome. Okay. Is my radical by itself? No. And when I say is the radical by itself, I'm asking right there. Is square root of 4x plus 1, is that the only thing on that side? No. So what are we doing?
Adding with 5.
Okay. If it's minus 5, I'm going to add 5. So I add 5 to both sides. So I still have square root of 4x plus 1. Minus 5 plus 5 cancel. 0 plus 5 is 5. Okay. What do I do after I isolate the radical? Okay, because it's a square root, we are squaring both sides. Okay, be smart. The square root of 4x plus 1 squared. 4x plus 1, yes? When you square a square root, you just get whatever's under it. 5 squared? 25. Not 10, right?
Right.
Get that silly answer out of your system. Okay. And we can solve from here, can't we? Okay. Undo the operations. If it's 4x plus 1, we want to undo plus 1, and we want to subtract 1. So 4x equals 25 minus 1 is 24. If it's 4 times x, dividing by 4, x equals 6. I guess I told some people you didn't really need calculators, but
I got 1 as an answer, so I was like,
No, I forgot to do that too.
okay. I see exactly what you did, yeah. And I think what you have to watch out for, when we square the left side. When you square the square root, it becomes itself, doesn't it? But the square root's disappearing in the process. So then on the right, 5 squared isn't itself, because that's not the square root of 5. So that's where, yeah, easy mistake to make. I'd rather you get the mistake out of your system today, right? Okay, questions on this section? Okay, moving along then. Okay, obviously, you know, this is example 2. You guys know how math notes work. We're adding a level of difficulty, right? On the first set, they were just basic square roots, and we had 1 square root. So your job was to isolate it. Now, down here, we have some different things happening. Okay, so we're going to talk about different ways to do this. As we look at A, we really don't even have a radical sign, do we? However, instead of a radical sign, what we do have is we have a fraction exponent. And that fraction exponent is a radical. Now, there's 2 ways I could teach this. I could change that to a radical, and that is one option. The other option we could do, because we talked about raising things to powers, right? And what I'm going to teach on this one is we're going to worry about trying to get rid of that 2/3 power. Now, before I do that, the same idea of isolate the radical. This time I'm going to say, okay, can we isolate the parentheses that have the power? In other words, as I talk about isolating this, can I get x plus 1 to the 2/3? So the parenthesis raised to the power. Can I get that to be the only thing on the left side?
Yes.
What needs to move away from that parentheses raised to a power? The 3. How do I move that 3 away? If it's 3 times those parentheses, we're going to need to divide. The opposite of multiplying is to divide. If I divide the left by 3, we're going to divide the right by 3. So now I have x plus 1 to the 2/3 power equals 4. So just like the last one, is my radical isolated now? It's not a radical, it's parentheses with a fraction exponent, but it's isolated. Now, we're going to raise this to a power. And we raise a power to a power, we multiply them. So the idea is I'm going to multiply this power of 2/3 by another power that's going to give me a power of 1. 2 over 3 times what is going to equal 1? 2/3 times what will give you 1? 3 over 2? I'm going to raise this to the reciprocal power is what I'm going to do. Okay? And this is one option. There are other options out there. But I'm going to take this whole left side and I'm going to raise that to the reciprocal power, 3 over 2. Now, if I raise the left to the power of 3 over 2, guess what? We're going to raise the right to the power of 3 over 2. Okay, on the left. There's a couple of tricks I have to point out on this problem. So let's work our way through them. On the left, x plus 1, and it was to the 2/3 raised to 3/2. A power raised to a power, you multiply them. What's 2 over 3 times 3 over 2? 6 over 6, which is 1. So what's x plus 1 raised to the first? It's x plus 1. Now, I'm going to encourage you, we need a value for 4 to the 3/2. So, you know that rule about being able to go between a fraction exponent and a radical? I still want you able to do that. So right here, if I put 4 under that radical, 2, 3, or 3, 2? It's the 2 is the denominator, so it's the square root of 4 to the third. Right? Now, there's one catch I need to throw in right here. We technically just did what to both sides? We raised them to the 3/2, which means we took the square root of both sides. Okay? I don't know if you remember this from, would have been first semester. When you take the square root of both sides, what do we have to put in front of this right side here? Plus or minus. And that is because we took the square root. And I'm going to write a side note up here. I think, how have I written this in the past? So right here, I'm going to say if the denominator or radical is another way to talk about it. No, wait, I shouldn't say radical, I should say root. Dang it. If denominator or root is even, use plus or minus. And that's the rule right there, okay? So when you raise both sides to some type of even root, in this case it was a square root, we're going to use plus or minus because we just took the square root of both sides. And it just means there's going to be 2 possible answers when we get to the end. Okay. Let's clean up that right if you haven't already. Unless you have a question. If you have a question, stop me. Ask. The left is x plus 1. The right, plus or minus. Now, you can do this one of 2 ways. I personally am going to do the square root of 4 and then raise that to the power of 3. Because I can do that in my head without having to grab my calculator. The other option is you can do 4 to the third and then do the square root of that. So, I'm going to say what's the square root of 4? 2. What's 2 to the third? 8. So this is plus or minus 8. Now, some of you that went the other way, 4 to the third is 64, and the square root of 64 is 8. Did we meet in the end?
Yes.
Yes. So, point being, it doesn't matter whether you do the root or the power first. How do I solve? I have x plus 1 equals plus or minus 8. We have to subtract the 1, yes? If it's x plus 1, I'm going to subtract the 1. What am I subtracting the 1 from? Are you seeing I'm going to have 2 answers here? Yeah, we're going to subtract 1 from 8 and negative 8. So we're going to have 2 answers. Now, if it benefits you, you could write this out as 2 statements. X plus 1 equals 8, or x plus 1 equals negative 8. Okay, if you don't need to write it out as 2 to see it, that's fine. But then when it's x plus 1, you guys already told me we're going to subtract 1. We get 2 answers. 8 minus 1 gives us an answer of 7. Negative 8 minus 1 gives me an answer of negative 9. So you would have 2 answers there.
You won't write them in like a ordered pair.
Math Excel will probably have you put a comma. So it'd be like 7 comma negative 9. I wouldn't say ordered pair because ordered pair makes me think parentheses. Does that make you see what I'm saying there?
Yeah.
But Math Excel will probably have you write 7 comma negative 9 would be my guess. They'll just say put a comma between them. Okay. Got that idea? Ready to try another one? Maybe, maybe not.
Maybe.
Okay, let's try B. Now, do you realize what that's reading as? 3 times the fifth root of x plus 1 to the third plus 1 equals 25. Okay. I'm going to ask you, is my radical isolated? That's a big old no, isn't it? Because if my radical is isolated, then I've got that radical right there by itself. And that's definitely not right there by itself. So, 3 times a radical plus 1 equals 25.
Subtract the 1 plus signs.
Yeah. Think of it as 3 times something plus 1. What do we usually do? The first thing we do is if it's plus 1, subtract 1. So now I'm going to have 3 times this radical, which is the fifth root of x plus 1 to the third. And that's going to equal 24. Okay, so is my radical isolated now? No, it's 3 times the radical. If it's 3 times, I divide by 3. On the left, the 3 out front and the divide by 3 will cancel. Fifth root of x plus 1 to the third equals 8. Now is my radical by itself. Yes? Okay. So, how, and there's 2 different ways that I could teach this. I see a radical, yes?
Yep.
How can I get rid of this radical? Keep in mind, this radical is a fifth root.
To the power of 5.
Okay, to the power of 5. Think back to the top 2 examples. How did we get rid of radicals that were square roots? If it was a square root, which has a root of 2, we raised it to the power of 2. Since this has a fifth root, we can raise it to the power of 5.
How would you do with the power of 5 if it's already raised to the power of 3 on the inside of the radical?
We'll deal with the 3 in the next step.
Okay.
Now, and I will say the other option, if some of you are out here trying this and thinking it, you could also, instead of raising to the power of 5 right now, you could change this as x plus 1 to the power of 3/5, and then raise to the power of 5/3. And if you're saying, what did you just say? Forget what I just said. Okay? But we'll deal with the 3 in a moment, because that's part of what's under the radical. In order to get rid of a fifth root, I'm going to raise to the power of 5. What do I do on the right? What we do on the left. So we're going to raise to the power of 5. Okay, on the left, I have the fifth root raised to a power of 5.
Now you just have x plus 1 to the power of 3.
Okay, we have whatever's left under that radical, which was x plus 1 to the power of 3. You have 2 options here. You could actually leave it as 8 to the 5th for the moment, or you can let your calculator do the work on whatever 8 to the 5th is. It's some big number.
32,768.
Okay. What was that number?
32,768.
Okay. According to Justin, it's 32,768. You can write that number, yes? You got a calculator, use it, that's fine. Now, I have x plus 1 raised to the power of 3. How do I get rid of a power of 3? Yeah. If it was a power of 2, we'd take the square root. Since it's a power of 3, we're going to take the cube root. So I'm going to do a radical and put a little 3. I'm going to do a radical and put a little 3.
Is it possible to go higher than like 5?
Mhm.
Like having to take the whatever route.
Yeah, you can do whatever you need to. Okay, on the left, the cube root of x plus 1 to the third. What happens to those 3's?
They cancel.
They cancel each other out, and we're left with
Square root of x plus 1
not even the square root of x plus 1, just
plus 1.
x plus 1. You can see the light at the end of the tunnel maybe if we're just left with x plus 1. Now, on the right, some of you already did 8 to the 5th, and you have that big old 32,000 number. And now you're going to put that in your calculator, and you're going to do the
Square.
cube root of it. Me personally, I didn't do 8 to the 5th because I didn't bother to pick up my calculator yet. I'm going to say, remember, you can do these either order, right? So Justin's already done his on the calculator. He's got an answer to match up with me, I'm sure. But I'm going to say, okay, the cube root of 8. Do I know the cube root of 8? That's 2. That's one that's on our blue paper, right? Then I'm doing 2 to the 5th. Well, I'm the math teacher, so I know 2 to the 5th. You may or may not. But 2 to the 5th is 32. If you did 8 to the 5th and then the cube root of it, guess what you get? 32. Did you do it, Justin? That's what I figured. So, I know. I told Alexis you don't really need a calculator today, which I haven't used one, but some of you are, and I get it. Finish me off. Am I done?
No,
X equals 31.
that was x. 31.
Yeah. Okay. If it's x plus 1,
Subtract.
we're going to subtract 1, and you guys are telling me
X equals 31.
x equals 31.
I did the next one.
Huh?
I did the next one.
You did the next one? Okay. Well, let's try the next one.
I took a leap and tried it.
That's good.
Why do you like with the 5? But why you do it different with the 3 and with the 5? Like in one you put the cube root and in the other you put.
So in this step right here,
Yeah.
it was a 5th root right here. So I was raising it to the power of 5 to get rid of it because it was a 5th root. And so this 5th root cancels with this 5. And then I just have what's in purple here, x plus 1 to the third.
And you can do the same with the 5.
Yes. Wait, what did you just ask?
I mean, with the
So basically, you're just switching
but
steps.
why with the 5 is like parentheses and with the 3
Hello.
you put the square.
Because the x plus 1 to the third is already raised to the third power, so you have to do the cube root to like undo it basically. To cancel it out.
Oh, it's like the opposite.
Yes, it's the opposite
Okay.
steps basically. Yeah.
Okay.
Okay. Fine. Isadora, can you head to, you're wanted in the high school office? Okay, so you can go ahead and take your stuff because we've only got like 6 minutes of class left, okay? Okay. Did we get Paula's question answered?
Yeah.
Okay, you're
I
good.
explained it best I could.
And there, if you did this, there is another way we could do this. So you may have done it, did you do it a different way? Because there is a possible different way you could do this and it would still work out as well. So if you work it a different way and get the same answer, your way possibly works. Okay, so I can look at it later if you want me
I
to,
told her
but
basically you're just flipping steps instead of doing like changing.
okay. C. I should have said before I answered the phone, work on C if you haven't already. Did you guys happen to do that on your own?
Yeah.
I should have said that. If I go to answer the phone, try and answer the next problem. My brain wasn't thinking. Okay. I'm going to want you to isolate. What are we isolating?
The x plus 3 to the third.
X plus 3 to the 2/3, yes? What do I need to get away from the x plus 3 to the 2/3? The times 2. So to move this times 2 away, divide by 2. So then I have x plus 3 to the 2/3 equals 8 divided by 2 is 4. And I should have left a little more space there in my anticipation. Okay. This one is a lot like A, the example right above it. How do I get rid of a power of 2 over 3?
You take the power of reciprocal.
Okay, we raise it to the reciprocal power. So to get rid of 2 over 3, I'm going to raise to 3 over 2. X plus 3 to the 2/3 raised to the 3/2. 2/3 times 3/2 is 1. It's x plus 3 to the 1st, or x plus 3. Now, 4 to the 3/2. Okay. Denominator 2, so it's the square root of 4 raised to the 3rd. Should have asked this question on the last problem, but I didn't. Every time you take a radical of both sides, we should be asking ourselves, do we need a plus or minus? What kind of root did I just do here? Square root. So do I need a plus or minus?
Yeah.
Yes. I should have asked this last time. Last time we did a cube root. Do we need a plus or minus on a cube root?
No.
No, only even roots. Okay? So that's why I didn't do it here on B, but I am on A and C. Okay? Let me clean this up. X plus 3 equals plus or minus 8. It's the same numbers we used earlier, isn't it?
Yeah.
But, reminder, the square root of 4 is 2. 2 to the 3rd is 8. How do I solve? If it's x plus 3, you're going to subtract 3. How many answers are you getting? 2, because we're subtracting 3 from 8 and negative 8. If you need to write it out as 2 equations because you see it better that way, go for it. X plus 3 is 8. X plus 3 is negative 8. We get answers of 5 and negative 11. Well, I don't know if I should really teach D in 3 minutes or not, but what's different about D?
You have two.
There's 2 radicals. Okay. When there are 2 radicals, when there's 1 radical, our rule is to get it by itself. When there's 2 radicals, your rule is to get them on opposite sides.
So
Opposite
three
sides?
radicals.
3 radicals is a whole nother story. We're not going there right now. Okay?
Just add the square root of 3x.
So yeah, if we're trying to get these on opposite sides, if it's a minus square root of 3x, I'm going to add square root of 3x to the other side. So then I have square root of 4x minus 2 equals square root of 3x. I have a radical on each side. How do I get rid of radicals?
Square root.
How do we get rid of a square root? We raise it to the power of 2. What I do to the left, you do to the right. What happens when you square the square root of 4x minus 2? It's 4x minus 2. What happens when you square the square root of 3x? 3x. Now you have another middle school equation, although a little bit more difficult than the others we were doing, right? I don't know, what do you guys do here?
I don't know.
I would do subtract the 4x. Then you have negative 2 and negative 1x, and then you just get 2.
If you already have an x over here with 3x, you could subtract 4x to join it. So then you have negative 2 equals negative 1x. And then you would have to divide by negative 1. And x is 2.
So you only have one answer for this one?
So you only have one answer for this one. It happens sometimes. Okay. You can get started in homework. You you don't quite know enough to do everything, but you know enough to get started. Lesson 6.5 in Math Excel will be due on Tuesday. Okay? And if that's not accurate in Math Excel, I will get it to reflect that.